Makes it look kind of cool, doesn't it? Floor grinder. Okay, so moving from the concept, just look at the design and simulation, the engineering side of the business. There's a few areas that we've improved on, and a few things that we've added. So, Inventor. Everybody, if you haven't heard of Inventor, you should have a look at Inventor. It's a great piece of software. The new thing that we've added this year is the ability to get started on it in Inventor LT. So, a lightweight package for you guys. If you're just using 2D and want to experiment on 3D, this is the way to do it. Okay, so it's very inexpensive, and it gives you the full power of Inventor, but only in single part modeling. So very, very powerful. Also comes with some fantastic translators if you've got trouble translating information from one vendor to another. So let's have a look at Inventor. So some of the big things we've put in Inventor. Now this is pretty key, right? So this is using AutoCAD 2D blocks. So when you're designing something, you want to test the theory of how something is going to work and see if it's going to do and function the way you want it to. Instead of putting a lot of design intent in it up front and investing a lot of design time, you can actually do it in a 2D, 3D hybrid. This is pretty powerful stuff. So it allows you to check and verify your design before you invest too much time in it. That's pretty cool, right? So the next thing is this. So we've designed consumer goods parts. I don't know if anybody's in consumer goods, but if you've designed a part, you realise now down the track you want to mould that part. We've now put in a whole bunch of features for plastic moulding. Okay, so being able to split apart, putting things like grills and different vents, and being able to put bosses in and treating it like a plastic part wants to be treated, right? So lips and things like that. We've made a lot of investment in plastics, and I'll show you some more about that down the track. And this is the big one everybody really, really wanted. This release of Inventor, right? So this is full assembly FEA. So will this work the way I need it to work? Okay. So we can now go and do stress and load studies on this, and we can actually have the results. This is really important. We can have the results drive the model. So if I'm doing something that I know needs to be thicker, in this case, it's not giving me the results I need. Software will actually give you the thickness of what you need to make sure you deliver on the desired outcome that you want. That's pretty powerful stuff. Okay, so let's have a look at another area. So Revit one. Okay, anybody know what Revit is? Architects, right? I'm not talking about architecture stuff, right? But you think about most of the stuff that we manufacture, a lot of the stuff we manufacture ends up in buildings, right? So line fittings, tables, chairs, lifts, escalators, all that sort of stuff. So there's been a real push from our friends over in the architectural field to make sure that they can bring the stuff that we bring in, or we design the models, into Revit. So we have what we call ASM exchange. So it allows us to simply take an Inventor model like this, make some adjustments to it, make it really, really lightweight. Okay? So shrink wrap it. So you've got the outside, you know the envelope it's going to take up, and include some important points like where it attaches to the floor, where they need things to be attached to, how do you insert it, etc. Being able to bring that into a Revit model, so a BIM model. To bring it into building information modelling and do some studies on how that lays out within the building and where it fits within the building environment. Okay, that's pretty cool. So you're going to see a lot more of this down the track. The ability to interop between our softwares. So AutoCAD electrical. Who's using electrical? Who manufactures something with electrical content in it? What's everybody else manufacturing? Things without electrical content? Excellent. So AutoCAD electricals are a really cool product. So if you haven't seen it and you think you might, it's worth having a look at it, right? So some of the changes we made into electrical this year are great. So this is auto population of three-phase circuit. But the really cool thing about electrical going forward is the fact that it allows you to, it will actually go out and analyse the load on your circuit. And it'll say to you, okay, well, if you make these adjustments, we're going to use less power. Right? So from a sustainable design point of view, that's really, really important. And of course, if you know Inventor and Inventor Professional, it also ties into your design. It gives you the ability to look at your wire, looping, where it runs, and do things like automatically do certain very powerful. Saves an awful lot of time. So, Autodesk Algor. Who knew we bought Algor? Anybody know who Algor is? Vice President. Okay, so Algor is a really cool piece of software. It does multi-physics, it does fluid dynamics, it does all sorts of stuff that I learned when I was at university. Spent ages actually calculating out. It all does it automatically for you now. So, one example I want to show you today is say this is an engine and I'm building a toy car, right? And I need to attach a bracket onto this, and at the moment I've made it out of, say, metal. And I need to determine if I can make it out of a lightweight plastic, which is going to be more sustainable down the track. So I can do a temperature study on this. So this motor runs at X number of degrees Celsius right here, and I want to see where the heat dispersion is on this. Right? I can now tell exactly how hot it's going to get in 34 seconds and what the temperature is going to be here, and here, and here, and here. Okay, so it's very, very cool the way that operates. So if you've got a use for this, or you've got a study that you need to produce from a fluid point of view or from a physics point of view, have a look at this. Moldflow. Moldflow was another acquisition. So we now own the world's best-in-class plastic analysis package. Without a doubt, this is it. So I told you before, we've made a lot of changes with the inventor environment to make sure that you can now design plastic parts a lot more. Now Moldflow will allow you to analyse them and make sure that you're designing them right, and check things like fill time and if the product's actually going to mold properly from first go. So let's have an example. Right, so this is from the automotive industry, and the auto industry wants everything to go down the plastics part because it's lighter and it's going to take less energy to push the car away, etc. So it's the way of the future without a doubt, plastic. So this is a car bumper. We want to we want to have a look to make sure that it's going to fill, see if there's going to be any areas where it's going to have an issue with fill on them. So it's done a study, and basically it said, right, well, I can actually see it's going to fill okay. So the next thing we want to do is actually have a look at our injection points and have a look at our weld lines and see what the fill time is going to be. All right. So simply what this tells me is that if I inject here, here, and here, the last places to fill are going to be these two areas right here. Okay. And it's going to give, and I can analyse the temperature to make sure that the temperature is going to be right, so I don't end up with really bad weld lines like here, which I probably wouldn't want in this part because this is the front of the car, right? You don't want to see weld lines here and here. I might decide to inject it in 5 points and have the weld lines further out here and get the plastic to meet at a higher temperature, so you get less of a mark when you're